Hello everyone, welcome to the channel Learn Math with Shobita. Today I am discussing a topic from real analysis which is about supremum and infimum of sets of real numbers. Okay, so what do you mean by supremum and infimum? Let us see. If a subset of R is non-empty and bounded from above, then supremum of A denotes the least upper bound of A. If a non-empty set A is not bounded above, then we assume that supremum of A is plus infinity. If a subset of R is non-empty and bounded from below, then infimum of A denotes the greatest lower bound of A. If a non-empty set A is not bounded below, then we assume that infimum of A equal to minus infinity. Let us see some results and problems related to this supremum and infimum. Supremum of the set x belongs to Q, x greater than 0, x square less than 2 is equal to root 2. And this, let a subset of R be a non-empty set. Define minus a is equal to set of all x such that minus x belongs to A. Then supremum of minus A is equal to minus infimum of A. Infimum of minus A is equal to minus supremum of A. Let A and B be our bounded subset of R such that they are non-empty. Define A plus B is equal to set of all x plus y such that x belongs to A, y belongs to B. A minus B set of all x minus y such that x belongs to A, y belongs to B. Then supremum of A plus B is equal to supremum of A plus supremum of B. Supremum of A minus B equal to supremum of A minus infimum of B. Infimum of A plus B is equal to infimum of A plus infimum of B. Infimum of A minus B is equal to infimum of A minus supremum of B. Okay, next fourth result. Given non-empty subsets A and B of positive real numbers, define A into B is equal to x into y such that x belongs to A, y belongs to B. 1 by A is equal to set of all z which is equal to 1 by x such that x belongs to A. Then supremum of A into B is equal to supremum of A into supremum of B. Also, if infimum of A greater than 0, then supremum of 1 by A is equal to 1 by infimum of A. If infimum of A equal to 0, then supremum of 1 by A is equal to plus infinity. Additionally, if A and B are bounded sets of real numbers, then supremum of A into B is equal to maximum of supremum of A into supremum of B, comma supremum of A into infimum of B, comma infimum of A into supremum of B, comma infimum of A into infimum of B. So fifth result, if A and B be non-empty subsets of real numbers, then supremum of A union B is equal to maximum of supremum of A, comma supremum of B, and infimum of A union B is equal to minimum of infimum of A, comma infimum of B. Next result, if A subset of B, then infimum of B less than or equal to infimum of A less than or equal to supremum of A less than or equal to supremum of B. Next one, let S be any given set and let T is equal to set of all modulus of x minus y such that x belongs to S, comma y belongs to S. Then supremum of T is equal to supremum of S minus infimum of S. Let S be given non-empty bounded set in R. Let A greater than 0 and let A into S is equal to set of all AS such that S belongs to S. Then infimum of AS is equal to A into infimum of S. Supremum of AS is equal to A into supremum of S. Let b less than 0 and let bs is equal to set of all bs such that s belongs to s. Then infimum of bs is equal to b into supremum of s. Supremum of bs is equal to b into infimum of s. Next result. Let x be non-empty set and let f and g be defined on x and have bounded ranges in R. Then supremum of f of x plus g of x such that x belongs to x is less than or equal to supremum of f of x belongs to x plus supremum of g of x such that x belongs to x. And infimum of f of x such that x belongs to x plus infimum of g of x such that x belongs to x is less than or equal to infimum of f of x plus g of x such that x belongs to x. Now some illustrations. Every non-empty finite subset of R is bounded. Every non-empty subset S of R which has a lower bound has the infimum. Every non-empty subset S of R which has an upper bound has the supremum. Infimum of a set is unique. Supremum of a set is unique. The set n of natural numbers is bounded below but not bounded above. 1 is a lower bound. The sets Z, Q and R are not bounded. Now let us see some problems. Set of all form 1 by n such that n belongs to n. What is the supremum? Supremum is 1, infimum is 0. Here next minus 1 to the power n by n. Supremum is half. Infimum is minus 1. Okay. Next the set minus 2, minus 3 by 2 and so on. So here infimum is minus 2, supremum is minus 1. As n tends to infinity, this minus n plus 1 by n tends to minus 1. Next set 1 plus minus 1 to the power n by n such that n belongs to n. 1 plus 1 by n if n is even, 1 minus 1 by n if n is odd. So if you put n equal to 1, n equal to 2 and so on, you will get these entries 0, 3 by 2, 2 by 3, 5 by 4 and so on. So here infimum is 0, supremum is 3 by 2. Next some problems are given. Find supremum and infimum of the following sets. So see all the questions and solve them. I will explain in the next video. Thank you friends. Please share and subscribe the channel.